today we're going to look at section 3.3. What we're going to do today is we're going to apply the principle of Cpctc. We're also going to recognize some basic properties of circles. So if we know that the triangle MAT is congruent to the triangle BOY by angle side angle, what else can we conclude? So looking at the markings, notice that we have two sets of angles and the included side. Hopefully you notice that if we have congruent triangles, we talked about this at the very beginning of this chapter, we technically have 6 different corresponding pieces that are congruent. So if we already have 3, that means that there are 3 more things that are congruent based off of this information. Notice that we should have 1 more set of angles congruent and 2 sets of sides. Well, angle T and angle Y are congruent. Notice that I can use 1 letter because these 2 triangles are not connected in any way. There's only 1 angle T and only 1 angle Y. So now I want to look for 2 different segments. Notice that one of the segments is AT. That would have to be congruent to the segment OY. Once again, A is marked, T isn't, O is marked, Y isn't. So we have to follow that. The other segment would be the segment MT. That would be congruent then to the segment BY. Once again, M was marked, so was B. They had to be in the same spot. T and Y are also congruent. So those are the 3 things that we would have to know because we have congruent triangles. So that brings us to this idea of Cpctc. It stands for corresponding parts of congruent triangles are congruent. Remember, corresponding parts are things that we've talked about since the beginning of this chapter. But if we have congruent triangles, like we did in the previous slide, we knew that all those other pieces that were not marked in the triangle had to be congruent because they were corresponding pieces. So corresponding parts of congruent triangles are congruent. We call this Cpctc. Note, we can only use Cpctc after we have congruent triangles. Hopefully that makes sense. The whole phrase has congruent triangles in it. If we don't have congruent triangles, we cannot use this phrase. So let's do some proofs with this. So I'm going to go ahead and I am going to write down my first given, that the segment of SM is congruent to the segment of PM. That was given information, and I'm going to mark it in my picture. SM, I get 1 tick mark, so PM, I give 1 tick mark. I cannot go any further about that, so I'm going to move on to the second given. That angle, SMW, is congruent to the angle PMW. That is also given information. So if I follow the letters, SMW is this angle up here. PMW, this angle up here. I can't expand on that any further. I've run out of givens. Notice that what I'm trying to conclude, though, are not triangles. I'm trying to conclude that we have segments congruent. But if I can get congruent triangles first, then any other parts of the triangles are congruent because of that new idea of Cpctc. So I'm going to try to get congruent triangles. I only have 2 things that are marked in my picture. Remember, to state congruent triangles, I have to have 3 things. So since I cannot assume anything, I'm looking at the picture and I'm thinking, okay, well, these 2 triangles share a side. So I can say that the segment of MW is congruent to the segment MW. Notice that I was able to keep those 2 letters exactly the same because if I look at the angle right above, M is in the middle, W is last, M is in the middle, W is last. So that's why I knew I got to name that segment the same way. And so why is something congruent to itself? Well, that's the reflexive property. And now that I have 3 things marked in my picture, hopefully we are able to then have enough information from that to prove that I have congruent triangles. So if I look at the picture, I see that I've got a side, an angle, and a side. So I do have enough information. I'm going to say that the triangle, now I can name the first triangle however I want. So I'm going to name the triangle on the left, triangle SMW. Essentially, I'm going to name it just like the angle above. So then that means that I want to name that other triangle PMW. So like we said, based off the markings, we know that those triangles are congruent because of side, angle, side. If I go back through my proof to justify it, my first congruent side came from step 1, my congruent angles from step 2, step 3 got me my other set of congruent sides. But now that I have congruent triangles, we once again are trying to prove that the segment SW, which is this segment down here, is congruent to the segment of PW, this segment right there. Well, because I have congruent triangles, I know that any other parts of corresponding pieces are going to be congruent. So I am able to conclude what I'm trying to prove. And once again, I can prove this because of Cpctc. Corresponding parts of congruent triangles are congruent. Notice I was not able to use that until after I have congruent triangles. And there's my proof. All right, let's take a look at circles. So if I'm looking at the picture on the right, I know that point T is the center of the circle. Every point on the circle is the same distance away from the center. That's what makes it a circle, okay? It's a circle because it is a nice round shape that no matter where I go, I'm going to have the same distance from that center. So notice that we have 2 points that are on the circle, point A and point B. This last part here says that the segment TA, so if I was to connect those 2 points, that segment and this segment of TB, we call these the radii, okay? So you probably have learned the word radius in the past, but if you have more than one radius in your circle, we are going to pluralize that as radii. Okay, and notice that since B and A are the same distance away from T, we have a theorem. All radii of a circle are congruent. Once again, hopefully that makes sense. If point T is the center and all the other points are the same distance from it, from T to B, that has to be the same distance then from T to A. So all radii of a circle are congruent. All right, let's take a look at this proof. So anytime I'm talking about circles, you can write out the word circle, but here is a symbol. So we've got circle, and the point then next to it is representing that that point is the center of the circle. And it's important to know what the center of my circle is. So that's the only thing that's given to us. However, if we look at the picture, there are 4 points, A, B, C, and D, that are on the circle. If point P is the center, hopefully we are okay. Notice that from P to A, there's a segment. That's a radius. From P to B, that's a segment, another radius. P to D is a radius. P to C is a radius. And like we just talked about, all radii of a circle are congruent. So I can say that the segment PA is congruent to the segment PB, which is congruent to the segment PC, which is congruent to the segment PD. Once again, this is because of that new theorem. All radii of a circle are congruent. And then I get to mark all 4 of those the same. That's the only information that I have. Notice that we are trying to prove that the segment AB is congruent to the segment CD. I don't know that those are the same length. I will know that they're the same length, though, if I can prove that those 2 triangles inside the circle are congruent. They already have 2 things congruent. We need 1 more piece of congruent parts, and then we have enough to prove the triangles. Hopefully you notice that in this picture, we have vertical angles. Angle CPD is going to be congruent to the angle APB. And that's because vertical angles are congruent. They share the same vertex. They are directly across from each other. So I get to mark them the same. Hopefully now with the markings, we see that we do have enough to prove that the triangles are congruent. So triangle CPD is congruent to the triangle APB. And if you look at the markings, it's because of side, angle, side. So I'm looking for where did I have sets of sides congruent? Well, step number 2 had some. Notice that I can say that the segment of PA, which was in one of the triangles, and the segment PC that was in the other triangle, those are congruent. So there's step number 2. Step number 3 is where my congruent angles came from. Notice that I have to actually go back to step number 2 because that's where PB and PD, which were the other sides of the triangle, those are congruent. So in this case, we had to go back to the same step twice. But now that I have congruent triangles, remember, any other parts of those triangles are congruent. So we have enough to prove that the segment AB is congruent to the segment CD, and that's because of this new theorem of Cpctc. Corresponding parts of congruent triangles are congruent. So that's us applying the Cpctc and recognizing basic properties of circles.